Yeah.
So,
Hel-
yeah, I guess Samrit, we can start, I guess. Yeah.
Yes, Rituraj, sure. Yeah. Hello, everyone. So today we have with us Mr. Navid Manai, Mr. P.S. Allen, and Miss Brigette Ogwezi with us. So who will be taking on with this sustainability event session. So first we will have an introduction about them, and later on we'll go through the sustainability session, and later at the end, if in case you have any queries, you can post it in the chat box so that we can have the queries listed and take on. Meanwhile, let me introduce the speakers of today's session. So Mr. Navid Mane is a highly motivated and keen materials scientist who brings a wealth of expertise in materials design, production, and testing, as well as he has an extensive experience additive manufacturing and research on novel materials. Currently, Mr. Navid Mane works as an academic program manager at Ansys Materials and AM Engineer. We have also with us Mr. P.S. Allen. Mr. P.S. Allen holds a Master of Science in Physics and is currently an intern at Ansys. We are honored to have Mr. Navid Mane and Mr. P.S. Allen along with Ms. Brigette Ogwazi with us for today's webinar session on sustainability event, which will focus on eco audit report, material selection report, and social impact assessment for the phase 2 virtual round of BAJA SAEINDIA 2025. Please join me in welcoming them. Hello, Mr. Navid.
All right, thank you very much. Yes, I'm just having some issues with the mute button, so I need to click it a couple of times. Thank you so much for the kind introductions. That was very nice. So as mentioned, my name is Dr. Navid Manai, and all three of us who have prepared the following content that we're going to present today are part of the academic program in Ansys, where we support educators, researchers, and students in their teaching, learning, and research initiatives going forward. So today we are going to focus on the sustainability event within the BAJA SAEINDIA competition, and hopefully by now you have watched the detailed training. We have a 2-hour recorded training that I believe has been shared by the organizers, Ruturaj and the other organizers of BAJA SAEINDIA. If you haven't watched that detailed training video, which goes into, dives deep into how you can use the Granta Selector software for this sustainability event, how you can do environmental impact analysis using that software, how you can do material selection. It's about, I think, 2 hours, 2.5 hours of training. Highly suggest, if you haven't watched it yet, to have a look. We are not going to do a deep dive today. We're essentially going to do a summarization of the deliverables required for this part of the competition, the sustainability event, and we are going to explore a little bit on the social impact analysis of the sustainability event, where I'm going to hand over to Piers for that part to explore in a few slides what is expected. Okay, so let me start by offering, if the slides start moving, there you go. So let me start by talking about what the Ansys offer is for any student team across the world, and obviously this applies to everyone on the call as well. So within the Ansys academic program, we do have an offering of a partnership with student teams, and essentially the offer is that we would provide a set of commercial grade licenses to any student team that would like to use them in their design process. You would receive, when you are part of this partnership, you would receive a default package of licenses, which includes multiple licenses of mechanical, which you can do structural analysis with. You will receive fluent licenses, which you can use for CFD analysis. And as part of this package, you also receive licenses of Ansys Granta Selector, which you can use for materials analysis, including sustainability choices that you make in your design process. So hopefully everyone on the call has already used this QR code or the link mentioned here, and you're already part of this partnership with Ansys. That is the way that you can get access to the software that we are talking about, the Granta Selector software. If you haven't gone through the link and you're not yet a partner of Ansys, you need to use that link and the QR code to become a partner to be able to get the software to use for the sustainability event. Okay, that said, I'll also mention that not only you will receive, of course, the free package of licenses, but we do have a learning platform called Ansys Innovation Space. There you'd be able to find more than 350 courses that not only showcases how to set up simulation, how to analyze results, but also the physics behind the simulation in all different parts of Ansys portfolio for FEA, CFD, materials, electromagnetics, and so on. Within this learning platform, we have a dedicated space for student teams where you can find dozens of videos, essentially customized videos for student teams. A lot of them are for car-based or vehicle-based student teams, and you can see some of these courses mentioned here. These are completely free to use. You don't even need to register for them. They can help you learn a bit more about how to use our software. We also have videos there, courses there that teaches you how to use Ansys Granta Selector. So that could be a good self-learning tool for you guys to use here as well. Now, going to the sustainability event, I'm going to briefly mention the essentially different parts of the sustainability exploration that is expected of each team. And then we are going to look into the workflow that you can use to essentially get to the right deliverables for this part of the event. So what we are asking everyone to do using Granta Selector software is to run an eco analysis. This is done using a tool within the Granta Selector software. This tool is called Eco Audit. And so using the Eco Audit tool, you essentially, as you will see in the upcoming slides, put in your bill of materials into the tool and identifying how the components are created, what materials are used for each component, what you're going to do with them at the end of their life. Are you going to recycle them, reuse them, put them in the landfill? You also identify any transportation needs required. When you identify all the requirements mentioned in the Eco Audit tool, the software provides you with the environmental impact that this product would have regarding the CO2 footprint and the energy consumption requirements of essentially manufacturing and using that product. So this is what we mean by doing the eco analysis. At the first step, you put in the bill of materials of your car, and the software lets you know of the CO2 footprint of your car. After you do this, the software tells you which component has the highest impact on the environment. Essentially, if you go into the report generated by the software, you can identify what is the highest impact component within your car. And then in the next step, where we call selection for eco design, what you will do is use the material selection capabilities of the software to identify an alternative material that has a lower impact on the environment. This could be a material that helps with lightweighting, for example. It might be a material that has a lower CO2 footprint when it comes to manufacturing the material itself. It could be a material that is recyclable compared to the original material that might not be. So essentially finding a material that has a lower impact on the environment for that most impactful component within your car. When you have found this material, you will run the third step, which is essentially rerunning the eco analysis part that you ran in the first step. The only difference in this third step compared to the first step is going to be you will be using the alternative material that you identified in the second step for the most impactful parts of your car. So here you will be able to see by changing the material for this most impactful component in your car, how much you're able to reduce the environmental impact in regards to CO2 footprint compared to the first design, which you ran in the first step. That's the high-level steps of the sustainability event, but again, in the next few slides, I'll go step by step to showcase the workflow. Before going to the workflow, though, I wanted to showcase the deliverables needed within one concise slide. So when you run the first eco audit in the first step, you're able to generate essentially a report automatically by the software. So there is an option within the eco audit tool that you can use to auto-generate a report. It details all the choices that you've made for the eco audit tool and the results that you've been able to get. Okay, there is no analysis. You need to do the analysis yourself, but it provides details on the choices you've made and the results that you were able to get by using the eco audit tool. So that's the first report that you need to generate and provide to the judging committee. The second report is the report that you can, again, auto-generate by the software. When you run the material selection in Granta Selector, there is an option to auto-generate a report in which, again, the choices that you've made to do the material selection is available in that report, and the results that you were able to get out of the material selection is available in that report. So that's the second report that you need to provide. And the third report is essentially for the third step, so the eco audit that you run with the alternative material available in the bill of materials. And there, again, you auto-generate a report from the software, from the eco audit tool in the software, and that includes the choices that you've made for that eco audit and the results that you were able to get, including the comparison between the first design used in the first report and the final design showcased in the third report. But again, there is no analysis involved in any of these reports. The analysis comes in essentially in the form of the presentation that you will be making on the judging day. So there, obviously, you'll be preparing a couple of slides to discuss how you went through the sustainability event. What would be helpful to have in that presentation is the list of points that I've mentioned here. So analysis of all the reports that you have submitted, all the 3 reports that you've submitted to the judging committee, and also analysis of the trade-off between different aspects of selecting materials for the most impactful component in your car. Meaning that if, for example, imagine that the drive shaft in your vehicle has the highest CO2 footprint and you decide to choose a material that has a lower environmental impact, obviously, before going with any material, any alternative material, you should compare the engineering performance of that new material to the original material. You should compare the economic performance of this new material to the original material, meaning how much it would cost, for example, to buy the material, and also, of course, the environmental impact is explored within the eco audit reports already. But we are expecting you to have an exploration of the social impact here as well. Now, the social impact is not something that you'd be able to directly do within the Granta Selector software. However, there is data and capabilities within Granta Selector that can help you with exploring the social impact. This is what Piers will explore for you in a few minutes. But I just wanted to mention the deliverables. Essentially, within your slides in your presentation, it would be really nice to have 1 or 2 slides on the social impact analysis that you've been able to do from your literature review, from your research on the internet, and from the data available in the grant selector software. Okay, so let's jump into the workflow that if you use, it would be helpful to run through the sustainability event. I've included here an example bill of materials. This is not specifically the bill of materials that is expected of you. That has been communicated by the organizing team to you guys. So use that bill of materials. This is just an example for the purpose of going through the workflow. But you can see about 8 components here, and we are going to look into these within our sustainability event workflow. So as I mentioned, the first step is to run the first eco audit with the full bill of materials that is expected of you to consider. And here you can see that the bill of materials, you can put them into the components, essentially part of the eco audit. Each component requires you, for example, if you're looking into the body panels, the name of the component will be body panels. The material, you need to choose what material you're using for that component, the recycled content. Some materials, when you buy them from the market, already have some recycled content in it. So for example, if you're using a specific stainless steel, it is almost, yes, I should say it is very much possible that a part of that stainless steel is already coming from recycled materials from previous usage. So you can find that information within the grant selector software, or how much recycled content is used for each material, and you can also use data that you can find online. You need to mention what is the mass of each component. So in this case, the body panels, how much do they weigh? Then you identify how the component was manufactured in the primary process and the secondary process. So it could be, for example, that they were cast and then you use machining. Obviously, that doesn't make sense for a body panel. I'm just giving you examples of what manufacturing methods could be used here. For example, if you're doing machining, then the percentage removed would be relevant. If the secondary process isn't removing any material, then the percentage removed could be 0. Then you identify the end of life for the component. So are you putting the body panels in a landfill after you're done with them? Are you going to recycle them? Are you going to reuse them? That's what you identified here. And for example, if you're recycling them, how much from the literature do you think of that material can be recovered through recycling? Okay, so for each component, each of these 8, you identify everything in this bill of materials. Then you identify if there has been any joining and finishing used for these components. So for example, if there are any pins, bolts, welding, painting, anything like that has been used, you can include them here. You can include as much information as you think is necessary here. So you can identify all of the joining and finishing processes here. And then, to be honest, I mean, to do a comprehensive life cycle audit, you do need to include the transport and the use phases as well. But because it would be unfair on the teams available within the sustainability event to include transport in the sustainability event, we have decided not to consider the transport and the use phase, because teams might be transporting their cars from different parts of the country, and just because you are far further from the competition side shouldn't disadvantage you in the sustainability event. So we are not considering the transport and the use phase. You can leave them empty. You don't need to fill the transport and the use. When you're done filling the eco audit project, essentially you can simply click on summary chart, and the software shows you something like this. So you can see in different phases of life of your product, in this case your car, how much would be the CO2 footprint or climate change impact on the environment. You can also do the same thing for energy requirements. So here you can see, for example, the material phase obviously has the largest impact on the environment. If you click on, you should click on detailed report. This is the report that you offer, you essentially provide to the organizing committee as the first deliverable, okay? Within this detailed report, you're able to look into the material, or sorry, the component that has the highest impact on the environment. So for example, this is a screenshot of the detailed report of an eco-audit, and you can see when it comes to a detailed breakdown of individual life phases in the material phase, the component that has the highest, in this case, energy requirement is the drivetrain front hub. Again, these are example bill of materials. Your bill of materials will be different, but you can easily see in regards to energy requirements and CO2 footprint, what component has the highest impact on the environment, okay? So when you identify that, you move on to the next step, which is finding candidates for that component that has the highest impact on the environment, finding material candidates that would essentially lower this environmental impact. Okay, so for this, you will be using the material selection tools in Granta Selector, and you are able to consider the environmental impact of materials, technical performance of materials, economic impact of materials. So for example, you can see in this Ashby chart or bubble chart, as we say, on the y-axis, we have the CO2 footprint of materials per unit of stiffness, and the mass per unit of stiffness value for each material. So you can see we are considering the lightweighting capabilities, which is engineering performance on the x-axis, and the CO2 footprint on the y-axis, which is essentially considering the environmental impact aspect. You can easily create other charts that look into cost per unit of stiffness, for example, that looks into the economic aspect of materials. So using these visual charts that you can create in Ansys Granta Selector, you can identify a material that has a lower environmental impact compared to the original material that was used for the most impactful component in your car that you identified using the eco-audit report. Okay, so at this point, obviously, you hopefully have been able to find the material that from an engineering performance perspective, from an environmental impact perspective, and from an economic impact perspective, trade-off, you can decide if that material would make sense to replace your original material. However, we want you to go one step further and also look into the social impact of this new material choice compared to the old material choice. So at this point, I'll hand over to Piers. Piers, I'm going to keep sharing the slides, but let me know if you want me to move any slides.
Yeah, sure. Thank you very much, Naveed. And yeah, thank you for the introduction. Just to top it up, yeah, my name's Piers. I've got a master in physics, and I work at Ansys, predominantly in sustainability at the moment. And I'll just take a few minutes to talk about the sort of wider sustainability impact. And I'll pick up by basically looking at some of the words that Naveed just used. He made a really good point that in the trade-off analysis, we're looking at the environmental impact, but this is a sustainability event, not the environmental event. And so we actually should need to ask ourselves, what does sustainability mean? Frequently in literature, sustainability is considered as society, environment, and economy. Some people refer to that as ESG, others the triple bottom line. But essentially, we're trying to improve these three forms of capital in sustainability assessments. We would like everyone to sort of put themselves in the position of being a real engineer. And when you make these kind of trade-off decisions, they're not always based purely in engineering performance. In fact, there's other considerations that need to be made that consider things such as society. For example, if you carry out your material selection and actually the new material that you select requires a greater mass, could this place an increased amount of pressure on the supply of that material? Could that have, therefore, a greater impact on society, given the conditions where that material has come from? I mean, these are all really important dimensions that need to be explored. And so, yeah, on the next slide, I'll just start going into that, please, Naveed. Great. So I don't know how many of you are aware of the SDGs or Sustainable Development Goals, but they're a really nice basis to kick off these discussions. Essentially designed in 2012 and adopted in 2015, there are a set of goals that essentially are there to guide society and humanity to a more sustainable future. So what I've done on this slide is essentially carry out a very small literature review and collect the sustainability goals that are most important in the automotive industry. And you can see that these have a wide range of impacts, from life on land to climate action to gender equality, quality of education and poverty. And these may not have direct links that you can think of right now to the materials that you're literally selecting in your bit of materials, but actually they do. And we're going to explore that a bit and how you can sort of take into consideration these other impacts. So on the right-hand side of this slide, we've just got a very small example of a material selection decision between low alloy steel and carbon steel. And as you can see, there's a reduced quantity of CO2 per unit stiffness and mass. The replacement materials both materials can be recycled at the exact same CO2 cost, and both have the same exploitation, abundance, and annual world production. So from a sort of environmental sustainability perspective, we don't see too much difference. But actually, there can be greater impacts to both society and sustainability in general when we further break down these materials into their constituent elements. And so we can actually do this using Selector. And so on the next slide, we can see another example using these materials of what that looks like. So here we see both these materials broken down into their components. And we see, let's take, for example, an increase in manganese. So we see that manganese is actually leads to many mining pollutants and a big ecotoxicological impact to those extracting it themselves. And so what we're sort of suggesting is that when you say, okay, well, let's use this material, it uses more manganese, what kind of impact could that have? Well, if you're an automotive company, you know, the volume of material actually scales up to be massive when you consider how many cars also that they're producing. And so if you're placing more pressure or a greater requirement of that material on the industry, then it means that literally more of it's going to have to be extracted, which could propagate and greatly increase the impact rather than decrease the impact to the miners. So this is an example of a social impact. It's affecting the workers in this scenario by increasing your requirement of this particular material. But I also want to take a moment just to stress that sustainable impacts aren't always negative. They can be positive, and it's really important to understand these. And this is why it's plays into a trade-off analysis. So yes, in this scenario, with an increase in manganese, we're affecting miners. We also see in African nations that extract manganese that it enforces a gender disparity, another form of a social impact. And I've actually shown here that this impacts SDGs 3 and 4. But we also see, conversely, with chromite, specifically in India, it's been shown to have a significant impact on local species. This is a negative impact, but in our material decision here, we're reducing the amount of chromite that's going to be requisite for our design. So actually, we're relieving this impact and therefore relieving the impact to SDG 15. So you can see that there's basically both positive and negative impacts. Now, not all of this information can be found in Selector. It is going to require searching online and finding some sort of basic research that supports the impact that these materials or minerals have on the world. But don't worry, this kind of research is pretty ubiquitous these days and very easy to come across. We're not looking really for a huge granular breakdown, but more an acknowledgement to how this plays off in a trade-off analysis. So if we kind of run it back and look at this again, we want to be considering in our sort of reports that yes, there is this negative impact to manganese, but there is a possible positive impact in reducing the amount of chromite that we use. Now, which material you may end up choosing as a result of this is up to you guys. But what we're looking for is a sort of well-explored argument of the potential positive and negative impacts of your material selection, and also taking into consideration the fact that let's rearrange the scenario slightly and say that, okay, we are actually increasing the amount of CO2 that we're using in this material selection by a tiny, tiny amount, but massively improving the societal impact, as well as the overall cost of our product in general. How does this play out in a trade-off scenario? Should we actually be looking at taking that material because it's essentially more sustainable? And then perhaps in terms of our material selection, we can look at some other materials that we could replace to reduce the CO2 impact. Really what we're trying to communicate here is that sustainability is not just about a one-off decision-making process based on one or two variables, but many variables. And often the most sustainable choice that we can make is not based on just one of them, but considering all of them together and the overall impact that has. So this may look like considering it firstly at the material selection level, selecting our materials based on what we found out, and then basically summarizing that very briefly of the overall design and impact that design has had. Essentially just a well thought out process in addressing the social, environmental and economic impacts of your material selection decisions. So yeah, that is this slide done.
Very good. Thank you so much, Piers. At this stage, essentially, when you get to this step of the workflow, as Piers mentioned, you should have identified the alternative material for that most impactful component in your car. That determination of the alternative materials obviously can be based on a trade-off, as I mentioned, between the engineering aspects of the performance, the economic aspect of the performance, the environmental and the social impact aspect of the performance. Okay, so regardless of how you reach to this alternative material, hopefully the trade-off makes sense, and we will be looking into the trade-off within the presentation that you're going to provide in the judging session. At this stage, you are going to run the eco audit again with the alternative material instead of the original material for the most impactful component. So the only thing within the bill of materials would be changed for this step of the eco audit compared to the first step would essentially be the line for the most impactful component in regards to the material being used. Obviously, when the material changes, you might be changing the mass as well, because obviously the density of materials are different. So if you're changing stainless steel with an aluminium alloy, obviously the mass required will be different. So take that into account as well. So that line could be the line for the most impactful component in your car can be different in many different aspects. So it's mass, end of life scenario, the material being used, manufacturing process for that specific line within the eco audit could be different. So you run the eco audit again, and here you're able to essentially compare the results with the original design. So here you can see, for example, the green, or the, I don't know, we can call it darker green, it belongs to the original design, and the lighter green here is belongs to the new design, essentially using the alternative material for the most impactful component in your car. So you can see by doing that, by changing the material, you have been able to change the environmental impact and reducing it by 8%. All right. So this is the third report that you will be providing, the detailed report of the third step with the essentially second eco audit. This is what you will be providing as the third report, and which, as I mentioned, is auto-generated in the software. And the final step is the reporting of everything that you've done within the sustainability event. As I mentioned a few times now, there are 3 reports that are auto-generated from the software that you need to essentially take from the software and provide to the judging committee. And on the judging day, you will be providing a summary presentation, as I mentioned in the beginning, where you will be exploring the analysis of the results that you have reported in these 3 reports, as well as the exploration of the social aspects that Piers just provided an example of. So this is where you will be exploring everything that you've done, focusing on the trade-off within the material selection and the results of the environmental impact as a result of changing the material. With that, I think we are at the end of the presentation today. So we wanted to leave about 20 minutes or more for the Q&A because hopefully you have already watched the 2-hour recorded training and you might have some questions from that video or from what we presented. So yeah, at this point, I can hand over to Ruturaj or some other member of the organizing team to run the Q&A session. I don't know if you have anything on the chat.
Yes. Thanks, Navid. Thanks, Navid and PS for all the insights that you gave
Sure.
about sustainability event and about social impact assessment and everything. So I think so. We have a question regarding, regarding. I think Piers gave an example regarding SDG 12 and 13. That those the in the example the two materials that he compared over there, there was no impact on SDG 12 and 13. So I think so. There is a question regarding this, that how would how would something adversely affect SDG 12 or 13? Responsible consumption and production. So what does that exactly mean?
So we're not really looking at it from a perspective of there's always a binary impact or not. The example here is that take responsible consumption and production. Both examples can be recycled to the exact same CO2 cost. So what's happening here is that neither example more greatly impacts SDG 12 through a CO2 cost. Essentially, that would be responsible production as well as climate action, right? So actually the impacts are the same. There's a net impact to them, but given that in this scenario, this sort of highly isolated scenario, we're only considering two materials, they have the same impact, and therefore there's not one that's clearly better or worse than the other. In terms of what would be like a good or bad impact, we'd see, okay, one producing more or less CO2 than the other one, and therefore not being as responsibly produced. Conversely, a lot of the SDGs can sort of, I guess, semantically tie into each other. But in terms of like responsible consumption and production, again, we might look at mining conditions. So, I mean, I'm sure no teams are using it, but to take an extreme example, we can look at cobalt in the Congo. Its extraction relies on a lot of forced labor and slavery. That would not be responsible production. So yeah, in this isolated example, there's no clear difference between their impact, and thus there's no greater or lesser impact. So we consider the impact is the same.
I can also add that for every case, you don't need to be considering all the different essentially SDGs here. If you can identify a few of them that there is identifiable impact because of the change of material to an alternative material, I think that would be a good enough exploration of the social impact analysis in the presentation. And also, I would also suggest the teams to have maybe briefly have a look at all the different SDGs. There's very good resources online to understand what each of these SDGs includes and what are the example impacts. So maybe within half an hour to an hour, I think you can have a relatively good understanding of what each of these SDGs are about. So that will provide you with a bit more information as well.
Yeah. I mean, the SDGs presented on this slide are sort of, I guess, for reference and guidance, given that they're the most ubiquitously considered in the automotive industry, but it may not be limited to these. And yes, as Naveed said, there's no need to consider the impact to every single SDG, rather identify if there's an impact to a few of them.
Yes. So adding on to Navid's point, so we have I think so we have also shared a link to the United Nations website where all the 17 SDGs are mentioned. So the teams can also go through that, and again the 8 ones that are mentioned explicitly over here, I think are more focused towards material selection. Yeah. One more question I think so that the teams have is on what all material selection criterias can they use while generating the report too?
What are the material requirements? Is that the question?
Uh, like the performance indices that they need to consider.
Okay, so that entirely depends on what components they will be considering for material selection. So there are components that you would make. So let's imagine that you are looking into, let me just go back to here. So here, I think what we mentioned was that the drivetrain front hub has the highest impact on the environment. When we are looking at energy requirements, but it's the same with CO2 footprint as well. That would be the same component here that would have the highest impact. So looking at the component, it looks like the mass of this component is quite large. This is probably why it has this high impact on the environment. So essentially, when we are looking into replacing this material with an alternative material, it might make sense to have as objective of your material selection to do some lightweighting, okay? If your objective is lightweighting, then essentially a performance index mentioned on the slide would make sense to look into mass per unit of stiffness. So when you're running a material selection, if you're using the systematic material selection methodology by Professor Ashby, you need to identify a few design requirements, okay? So you need to identify essentially what is not only the objective of your material selection, but also what are the constraints of your material selection project. So for example, in the case of a drive shaft, you might be thinking that you require the material to be resistant to, for example, water. So you don't want to use a material that is easily susceptible to corrosion, for example. Okay, and also you need to consider another design requirement here, which is what is the first design requirement, Bridget? I forget the name of the first category of design requirements.
Function constraints.
Function, thank you. Yes, forgot about the function. Yeah, so you need to identify the function, which in this case, for example, you can consider the drive shaft to be essentially a bar, for example, in tension or a bar in compression. It really depends on which component it is that you have in mind. The Granta Selector software has a lot of example functions that you can choose when you're trying to select the right performance index. So depending on the function, the constraints, and the objectives that you come up with for your material selection project, that determines what is the right performance index to consider. So if you go to Granta Selector, when you identify these three requirements, the software does suggest a performance index for you to consider. Or if you have more time, or if you're familiar with deriving the right performance index, you can actually sit down and calculate what would be the right performance index here. But you don't have to. It is available in the software.
Thanks, Navid. One more thing, like I like to tell the teams is that, I think so. A few teams have also asked how to generate a material selection report from Ansys Granta Selector. So regarding that, I think so, as Navid has mentioned already, and I think so we have all the teams have already received a 2-hour training that was conducted by the Ansys team last year itself. And also we have shared a ANSYS innovation course in which all these things have been explained.
Yep.
So teams can refer those training sessions to understand that. Even after that, if the team is not able to understand, then you can contact like your alumni coordinators and will help you guys. Also, the recording of this session will be shared to all the teams. So yeah, I'm just checking for more questions. Just a minute. So yeah, if Navid, I think so. One question that the teams have is the last slide, I think so, that you mentioned that there should be a summary presentation. So if you can explain that once, like I think so, teams are a bit confused that do they need to actually show the report itself during the summary presentation,
No.
or do they need to summarize the content from the reports?
Yes. So the second option, essentially, what would be expected from you on the day that essentially you will be appearing in front of the judging committee. The summary presentation is what I'm referring to is the slides that you will be presenting on that day to the jury team. So within those slides, obviously we don't want you to have or show us the reports that has been created with the software. We already have them. You already submitted to us beforehand. We want you to be showing us analysis of the results there. So for example, you can have a screenshot of the material selection chart that you use in the second step, but we need you to be talking about why you think the alternative material that you've chosen makes sense according to that chart. Okay, you can say, for example, it provided more light weighting, which means that you were thinking of the engineering performance a bit more. You can say, from a social aspect, this made more sense because the impact of this new material compared to the older material on the specific SDG, for example, is significantly less. So that is what we want you to focus on, the analysis within your presentation. And obviously you will be using the results of the reports that you have generated before to be able to do the analysis. But the analysis is the main thing within the presentation.
Okay. Thanks, Navid. So I guess adding on to Navi's point, so the teams don't need to explain each and every the CO2 footprint for each and every component for that is present in the BOM. They need to summarize the total values. And again, if you're optimizing the material for a specific component, then you need to focus on that particular component only. Okay.
Correct.
Yeah. So I think so. Yeah, that's it. I think so. We have covered all of the queries, I guess. Yeah. So again, and this report that you will be generating for sustainability event is just specific to the sustainability event. Teams can use this reports for the material selection report for the CAE event that you have. But again, whatever reports that we have mentioned over here will be required for sustainability event itself. Rest, the team can choose how to present the information in other events according to their wish. Yes, I guess any ending remarks from your side, like Naveed, Piers, or Brigade?
Nothing from my side. Piers, Bridget, do you have any final remarks?
No, not personally. I think just looking at some of the questions regarding, the amount of stuff you have to talk about, and sort of how granular you should speak about these things. Certainly from my perspective of sustainability, it's just important to keep the big picture in mind, which is what do these trade-offs mean? What do these decisions mean? It doesn't have to be a super granular analysis, but rather just the big and most sort of important points that can be made about it. But other than that, no.
I can see lots of questions as well. And I think just to point out that we are running the sustainability event, it's relatively new, so don't worry too much. Don't worry too much about it. As you're working through, it's about learning and to understand the questions an engineer should be asking. So what we're really looking for is just what is the thought process? Are you thinking through these things and then presenting? And don't worry too much about it. It's fine.
Yes. Thanks, Rui. I think so. That is one point that the teams will definitely consider. That they don't need to go into nitty-gritties of all the things while presenting. and just need to focus on the high level trend. Yeah, I guess thank you, Naveed, thank you, Brigade and Piers, for joining in on such a short notice and giving such like an insightful presentation.
Of course, it's always a pleasure.
Okay. Yes, I guess we can close this then. I guess we are on time. Yeah. Okay. So thank you guys. Thank you guys for joining in. So we'll Sampreet, we can, I think so, close the meeting. I think so we have covered all the doubts as well.
Yes, sure, Ruturaj. Yeah.
Thank you so much. Hope you have a great day.
Thanks, everyone.
Thank you.
Thank you. Thank you.
Thank you, everyone.